Assalamu alaikum everybody. This is Saad Ahmed, and today we are going to discuss a topic, text analytics, and which is basically the natural language processing technique, and we will be discussing the theory as well as we are going to use Python to implement those tasks using the spider ID. So let's start. As we already know that text analytics has a lot of applications in today's online world, as 80% of the data generated on the daily basis is unstructured, especially with the popularity of social media. This unstructured data has increased very rapidly. So we know Twitter, Facebook, these are the medias which people use today to express their thoughts and ideas and sentiments. So by analyzing tweets on Twitter, we can find trending news and people reaction on a particular event. Also, management of any company such as Amazon or YouTube can understand user feedback or reviews of a particular product. They can also analyze and understand people viewpoint on a video or on any topic. So these are some of the examples which are present, and we are just dealing with them on the daily basis. So text analytics is the major thing which we need to understand to accomplish this basic task. So let's move forward and see what can be done. And for that, in today's topic, we are going to cover the basics of text analytics and NLP. We are going to compare text analytics, NLP, and text mining. And after that, we will be implementing those using a natural language toolkit on Python to perform tokenization, stop word remover, lexicon normalization such as stemming and lemmatization, POS tagging, and so on. So this will be the agenda for today's session. Let's continue. Okay, so text analytics and this NLP. Text communication is one of the most popular form of day-to-day conversation. We chat, message, tweet, share status, email, write blogs, share opinion, feedback in our daily routine. This is the era of social media, and all of us are actively participating in this. All of these activities are generating text in significant amount. As I told you that unstructured data that is generated today is 80% of the total data. So that is a huge thing. This area of online marketplace and social media is basically generating this unstructured data. It is very essential to analyze this data to understand the people's opinion. NLP enables the computer to interact with humans in a natural manner. It helps computer to understand the human language and derive meaning from it. It is applicable in several problematic form, from speech recognition, language translation, classifying documents, to information extraction. Analyzing movie reviews is one of the classic examples to demonstrate a simple NLP bag of word model on reviews of movies. So this is what basically NLP is, and it has a very strong importance in our today's world. Okay, let's look at the text mining, NLP, and text analytics. Text mining is also refers to as text. So these two are same thing. Text mining is a process of exploring sizable textual data and find patterns. Text mining process the text itself, while NLP process the underlying metadata. This is important. Finding frequency, count of words, length of sentence, presence, absence of specific word is known as text mining. Remember this. Natural language processing is one of the component of text mining. NLP help identify sentiments, find entities in the sentence, that is NER, and category of blocks and articles. It is basically the pre-processed data for the text analytics. In text analytics, statistical and machine learning algorithm used to classify the information. Okay, so this is the interface, the IDE I'm going to use to demonstrate and implement different NLP pre-processing tasks, and I'm sure you are familiar with this Python interface. The main target of further discussion is to understand the concepts and use Python to implement it to get results. So this is what I'm going to do here. This is the Python console, and this is where I'll be giving the instructions. These are the values of the variables in this pane, and on the left side this is the actual code, one of the actual code which I'm going to use today. Anyway, let's go back to the text. Okay, so first step is the tokenization step, in which what we do is break down a text paragraph into smaller chunks such as words or sentences. This process is called tokenization. Token is a single entity that is building block for a sentence or a paragraph. If you break a sentence into words, then it is called tokens, and if you sentence tokenize, then it means that you are breaking the text paragraph into sentences. But anyway, the tokenization is basically small chunks of words or sentences from a larger corpus or data, text data. Okay, let's see how it works out. We'll just give a sentence here, a paragraph with 3-4 sentences, and the text I have written is, hello Mr. Imran, how are you doing, weather is good and the city is great. And I want to just sentence tokenize it, but for that I will be importing this NLTK, and from NLTK tokenize I'm going to import sentence tokenizer, sent underscore tokenize, that is sentence tokenizer, and we can see that it has already been imported. So I'm going to just input the sentence here, the sentence goes in, and now I'm going to tokenize. The tokenization process has been done, and I'm trying to try and print the tokenization results. So after print tokenize, you can see that hello Mr. Imran, we have a comma, that means one sentence has ended, the next sentence has started, how are you doing, again a comma, then you can see the weather is good and the city is great. So this is how it works. Hello Mr. Imran, how are you doing today? This is one sentence, the weather is good and the city is great, the other sentence, and there is a third sentence, the sky is blue. So it has what it has done is it has sentence tokenize all the sentences present in the paragraph. The next thing I want to show you is the word tokenization, and for that we'll be using the word tokenize from NLTK. Again, I'm going to use that same sentence. You don't need to do it again, but just for the sake I'm just showing it. And now I'm going to print the words. See, you can see here that hello Mr. Imran, how are you doing today? Punctuations are also tokenized, so you can see that all the words are now tokenized, and you can separately identify and make a list of the words that are present in this paragraph or in a corpus. The next thing I want to show you is to find out which word has appeared how many times, that is the frequency distribution. So I'm going to use this NLTK probability and import frequency distribution. It's a very interesting thing, so I'm just going to apply it here. It is showing that 20 samples and 25 outcomes. Let's see how it looks like in a graphical format. So this is the way I'm going to import the plot library and plot it, and let's see how it shows. You can see here that this is the graph. On the x-axis we have samples of the words, all the words that appear in that paragraph of 3 sentences, and their distribution. On the y-axis you can see the counts. So we have is appearing about 3 times, comma 2 times, the 2 times, full stop 2 times, then we have hello 1 time, and all the other words. So this is how you can check the frequency distribution of words. I am showing here a very small paragraph and a very small result, but this can be applied to a very big data set or a corpus. Are considered as noise in the text. They may contain stop words. Text may contain stop words such as is, am, are, this, etc., which are not very meaningful. They are mostly grammatical words. They are for the grammatical purposes, and we normally remove these words in a pre-processing process. So in NLTK, for removing stop words, you need to create a list of stop words and filter out your list of tokens from these words. Okay, the next thing is to remove the stop words. First we will import the library, and then we'll set English as our language so that we get the standard list of stop words in English, and then we'll use this print stop words to print the stop words. And you can see here that these are the stop words. It's more than 100 words which are already present in the list, and you can also add and make a custom list if you need to add something to it. So this is what the list is. Next you will filter the words, and then we will just okay, let's see how this can be done. You can see here that I have imported the stop word list and set our stop words for English language, and when we print it we get these some of the words we can see here. And then I'm going to filter out the words from the sentences, and once I implemented this, you can see here that this was the word tokenization of sentences, and in the bottom here you can see that the word how are you are missing before today, which was here, and then the weather is good, so is was considered as stop word. So all the stop words, the sky is blue, the blue is removed from this list. So the thing is that all the words which are considered unimportant for any particular analysis can be removed using this technique. Next is lexicon normalization, which is considered another type of noise in the text. For example, connection, connected, connecting would reduce to a common word connect. It reduces relationally related forms of a word to a common root form, that is a common root word. So there are two processes. One is called stemming process and the other one is called as lemmatization process. And first we'll discuss this stemming. Stemming is a process of linguistics normalization which reduces words to their root words or chops of the derivational affixes. For example, we can use different type of stemmers. The most popular one is the Potter stammer, and you can see I've imported it here, and then I'll apply to a sentence which says that it is important to be very honest and work hard while you are studying. So I'm going to implement it and show it to you. So I have imported this new text, and then now I'm going to do is I'm going to apply it, and first I will tokenize the words which are present in this sentence, and if I want to see them printed I can do this, and you can see here the words will be there. Now I want to stem, and after stemming you can see the word important, this important word become import because it is basically chopping off the affixes. And according to algorithm which is called Potter algorithms, you can go and check the details of the algorithms if you like, but you can see some words are properly handled, but there are some words like this study become study, which is not a dictionary word, and you can see very becomes very VERI, again it's not a dictionary word. So there are some problems which you can find in Potter stammer implementation in the words, which because some words are not dictionary words, which can be a problematic thing for some kind of research, but for fast conversion or fast working you can use this Potter algorithm. Okay, the next other process is called nemtization process, and in this process it reduces the words to their base words, which is linguistically correct lemmas. So the technique is a little different. It transforms root words with the use of a vocabulary and morphological analysis. So it's a detailed process. It takes more time than stemming. Lemmatization is usually more sophisticated than stemming. Stemmer works on an individual word without knowledge of the context. For example, the word better has a good as its lemma. This thing will miss by the stemming because it requires a dictionary lookup. So lemmatization is better when you are using it because it is going to give you dictionary words. Okay, let's see. I'm going to import here the lemmatizer, WordNet lemmatizer. WordNet is another very good dictionary which can be, we'll discuss about it later sometime. Word net limitizer, because I'm going to use it now. I import it. Then let's see the first word import here. You can see that import will become import. See, imports become import. Cacti become cactus, which is again a correct word. Geese become goose. Look at the bottom of the screen on the right side, on the middle. Then the python, the rocks become rock, the python become python, python is python. Better is good as an adjective, and better, best is best as an adjective. Then run is run and run. Okay, so I have this sentence. It is important to be very honest and work hard while you are studying. This sentence is converted into tokens, and then I have applied the lemmatization process, and you can see now that the words are lemmatized. Remember, important become import. Now it is important. Very is still correct with the correct spelling, and study is also correctly mentioned. So using the lemmatization you get better results, but again it depends on the requirement. If you are working and looking for fast process of this normalization process, then stemming or potter stammer can be applied, and for the proper grammatically correct, vocabulary correct words, you will be preferring this lemmatization process. Alright. Okay, the final thing in this session today we will be covering is POS tagging, part of speech tagging, which basically identifies a word, whether it is a noun, pronoun, adjective, verb, adverbs, etc., based on the context. And basically there are many POS tag sets, and here we will be using Pantry Bank tag set. And POS tagging looks for relationship within the sentence, assigns a corresponding tag to the word, and let's see how it is implemented in the Python. Okay, here we have the sentence. This is very good that POS tagging works, and I'm going to apply it here. You can see that this is the process I have created, and I want to just run it, and you will be able to see the results shortly. We have to so after implementing the process, you can see that the words are marked with their POS tags. This determiner is verb, very, JJ adjective, and so on. So this is how POS tagging, and this tagging can later be used to identify and filter out words according to their tags, and then we can use these words for further processing in basically machine translation, question answering, sentiment analysis, etc. So that is it for today. Hope you have learned something during this session. I want you to apply this and check the results for yourself. Thank you very much. Allah Hafiz.